So as Pete said, my name is Gil Emery. I'm the Federal Solutions Architect for Chef, and we're here to talk about how to run Chef in an offline world. So who am I? I work with the federal government and our system integrators. Is that Department of Defense, civilian, or IC? The answer is yes. Chef is a small company. I handle all of those accounts. So what I do on a day-to-day basis is I help people understand how to use Chef to solve their problems. Right? That's really what we are at our core. We want to make sure that people understand how to use the tooling, how to operate appropriately for what they're up to. So that's what I try to enable. I used to be a Windows Server admin, so if anybody looks at any of my Linux code in this demo, you're going to cringe. So I apologize in advance. But yeah, that's just who I was. And as Pete said, I've been with Chef since March 2014. So what we're going to talk about today is obviously running Chef in an offline world. So to get us started, we have some prerequisites and assumptions about your environment that we're going to need to cover. I'll talk about some of the concepts we're going to cover, the things inside of Chef that we're going to operate with, and how Chef communicates, so we understand some of the security model that you're probably also concerned about as we go through this. The plan of how we deploy Chef in an offline world, like what does that look like, how does that operate? Followed by, we're going to see it in action, and then any other resources we have to get you going on this process. So for some prereqs, first thing we need is you need some networks that you want to deploy Chef into, right? Like you have to have the thing that you want to put this on. We need a really kind of basic level of Chef concepts and terminology. I'm going to be using Chef provisioning and some Chef cookbooks to make this happen. So if you don't know what those are, definitely ask me, we'll definitely help you guys out. But it's really kind of basic stuff. You need a set of cookbooks that you want to run inside of your environment. And then you also need servers for all the things, right? So you're going to need a server for each piece of the environment you want to build. So the first assumption I have is that you know, that I know, that you know how to get code into your offline environment, right? So I'm not going to cover the methods that happens. For some of you, it's literally burning a DVD and walking it into the skiff. For some of you, it's a USB key because you still haven't read about Stuxnet. So there's a whole bunch of ways that we get into that. This isn't talking about that. In this particular demo, what I have is actually having a VPC of an Amazon. One system has internet access. Nothing else has internet access. So I'm RDPing into that system, and that system is what I'm using to push code into the offline side. The other assumption we're making is you're going to have a workstation inside of your environment to work with. So that's going to be kind of your loading point, if you will, for getting code inside this environment. You're going to have root level access to all the systems you're working with on the to install Chef onto, or similar sudo level access as well. And then the systems are online and have SSH access into them. Those are the kind of the three basic assumptions we're making as we go through this process. So what I'm not going to talk about is about the culture or the process on how to do DevOps securely. There's lots of great talks on those processes and how to do it in the enterprise here at ChefConf. The first talk you should check out for that is going to be DevOps in the IC, run by Michael over at MITRE. That's next at 2 o'clock in room 203 and 204. Also, anything in the transformation and continuously Chef tracks are built for that kind of purpose and talking about those pieces as well. So what this talk is about identifying the packages necessary to run Chef offline, define the process that we're going to go through to install Chef, any modifications we need to make to the process to make that happen, and a way for me not to have to work the booth. So that was a big bonus for me. So the next piece here is, I've done some stuff I'm not proud of, and the stuff I am proud of is disgusting. Again, the idea here is this is proof of concept. I really want to show you guys the mechanism, the process to make this happen. This is not a code review of my code, though please do. It is up on GitHub. Please do come in and contribute and help out. Let's make this better. But really, the core components of what we have today is just how does this work? What's the steps I need to do? What's the order I need to do this in to make this work and be functional? All right. So, a couple of the concepts we're working with today. We're working with Chef provisioning. You can easily do this with Knife Bootstrap as well. I chose provisioning just because that's the one I wanted to use for this talk. It's easier to put into recipes than Knife Bootstrap is. We're using some Chef cookbooks and Chef recipes, and we have some gem management stuff that we're going to talk about in the process as well. For communication, for the most part, it's 443 for Chef client interactions to the Chef server. This is a public-private key pair interaction. If you're familiar with the way Chef bootstraps, when a Chef client comes on to the Chef server, it's going to have a public-private key pair generated as part of that initial interaction. That key can then be rotated. You can do all the security management stuff you want to do with that and go from there. SSH, right? I need to get into the boxes to get the first things going, so you need to have some inbound access there. If you're using ops code push jobs, if you're using the push job server, you need ports 10,000 to 10,003 open for that. And everything is pull, except when it's not. But even the stuff that's pull, that's not pull, so push jobs itself actually still operates in a pull model from a network standpoint, and that we already have a connection. It's an outbound connection to the Chef server, not an inbound connection to the nodes. You can actually build Chef in a way that you have no inbound connections to the nodes you're managing. So no SSH, no RDP, none of those pieces. We have enterprises and agencies that do run that. And I apologize for the projector issues.
Hey, real quickly, can we have, if we can have a couple rows squeezed closer together, we've got actually overflow in the hall. That would be awesome. We can make a little bit of room. Thank you.
All right, thanks, Pete. So let's move on to the plan. What are we actually going to do? So this is the basic order of operations. We're going to build the workstation that we're going to use to bootstrap things. We're then going to build a Chef server, we'll build a supermarket server, go back into building the workstation, getting it connected to all those pieces. And then if you're interested in the premium stuff that Chef has, and the compliance and automate visibility pieces, we'll go over that as well. So the first part of the workstation is the loading dock, right? So this is the way that we're going to get stuff into the rest of the environment. Again, so if you're working in a place where you have to load onto a DVD and walk it over, this is the system you're going to want to build on the other side of that piece that's going to have the tooling necessary to make things happen. So the stuff you're going to need is you need the Chef development kit. Duh. That's the first thing we're going to need. We need any gems you're going to use. So if you're going to use provisioning, so you need to make sure you get the provisioning gems over to that system as well. If you're using Knife Windows to do Windows system, Windows bootstraps, things like that. You need a file server of some sort. As you go through this process, eventually you're going to move into true artifact repositories and things like that. For the purpose of this demo, I chose running an FTP server and a way to create artifacts so they're easier to move than moving whole directories. So the Chef server is the first thing we're going to build because it's our central repository for cookbooks. It needs to be up so the nodes can check into it so we can pass policy into the systems. So the things it needs is the Chef server core RPM and the Chef manage and ops code push jobs if you're using the premium features. The ports you need inbound 443 to it, and you need inbound 10,000 and 10,003 for push jobs, and you do an outbound 443 to the automate server to get some of the visibility data out of it as well. So the first step is to install Chef Client. How hard can it be? It's just a package, right? So the Knife Bootstrap / Chef Provisioning will grab and install.sh from chef.io. That's their default behavior as you go to run them. Install.sh is 692 lines of code. Okay? So it's a lot of code for you to go through and read, and I'm going to quickly just take a quick look at it and just scroll. It's big, and it has a lot of things inside of it. And so what it does is it does a lot of logic. It figures out a lot of things about your implementation here, so you can make the right decision for which package we want to download for your implementation. So it determines what platform you're on. Are you running 32 or 64-bit? What channel do you want to install from? Do you want the stable version? Do you want the current version? Do you want to specify a specific version you want to pass in? Do you want to install Chef Client or Chef DK, right? What's the actual package you want as part of this process? So the point here is that what you want to do is you want to build your own install.sh for what you're using. For today, all I'm doing is I'm running all my systems on Red Hat, so my install.sh is really simple. It's grab the Red Hat Chef Client RPM and install it. Real straightforward. Your environments are going to look a little bit more complex, but again, build them to what you need. If you want this code, install.sh from chef.io is open source. Feel free to grab it, modify it, do what you want to it, specify your own package locations, etc. On the Windows side, we have a very similar thing. We have a PS1 script does a similar process. So, all right, so now I know how to get Chef Client on there. That's great. Now I'm actually going to install Chef Server. I'm using Chef Ingredient, which is a cookbook we have to help you manage Chef servers in an idempotent or in a test and repair loop fashion. Chef Ingredient enables the dynamic configuration of the packages. It also allows me to call package source, which is really nice and easy. So it allows me to specify directly where I want to get the files from. And so I'm using FTP in this case. It's great, but it requires mixlib install, which requires mixlib versioning, which requires blah, 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 right? So we now start getting into gem dependencies, and it's turtles all the way down, right? Gem dependency management is not always forgiving, and so there's a couple ways to solve this problem. The first way, which we all try to do initially because we're dumb, is download, try to install, download the next one, try to install, and then you quickly realize there's got to be something better. And you're like, well, maybe I just skip Chef Ingredient, right? I'm just doing an RPM-UVH, right? Like, I could just go execute that. That's doable, but in terms of building your systems repeatedly and dynamically, that becomes really hard to manage, right? You have to write guards around it. You can do things like that, but you also don't get the leverage, the Chef Ingredient and the other tools that we're going to be working with. You're also just kicking the gem problem down the road, right? You know that you have to solve the problem at some point, so you better just figure out how to solve it now. So, fine, I'll just mirror Ruby gems. That sounds good. Okay, I need a C8 or C4 8XL and a lot of hard drive space because I have to mirror 80,000 gems, right? And we're also talking about running this into a high-side environment. I just downloaded 80,000 gems from the internet, right? There's no way that I went through them. There's no way that I understand what they all do. So that doesn't work either. So what we really want to do is we want to install what we need into a directory on the low side, right, as part of our development pipeline, and then move that directory over as an artifact. So this is what I mean when I talk about targeting an artifact, is this is what I did, right? This is the dirty version of it. There's better ways to do this as you go forward. But the idea here is we want gem install-i, which will put it into a path, and we tell it what gem we want. It'll grab the gem, it'll grab all of its dependencies. Again, we're doing this from a network-connected machine, so we have access to Ruby gems to make all this happen for us. And then we're going to create a tar of this, and that tar is what we're actually going to bring over to the high-side environment. And what this does, actually the benefit, is that I have a moment-in-time artifact of the gems I'm using. So when I build this stuff on my low-side environment, when I build out my pipeline and I'm working through my workflow, I know explicitly which gems I use, and I know that I'm explicitly getting those gems into my production environment. And that's a really powerful thing for us to have. So again, this is ideally done as part of your development pipeline. So you should do that as we go through the process. All right, so back to the Chef server. I've got Chef client installed. I've extracted mixlib install and dependencies into the Chef client's gem path so that it can find them. Chef ingredient now knows how to configure the package I want and where to find it. So we install Chef. And that's what I'm going to show you guys right now. So the first thing I'm going to do is show you the security group I'm working with on my system so that I'm not lying to you about the rules that apply to my systems. This is the security group, outbound, restricted only to the same subnet they're in. Inbound is the same rule. So I have a bunch of systems here. I'm going to grab, let's get state running. And this is the one I want. So his IP address is 10.152. Security group is default. It's the same security group we had there. All right, so moving over to my remote session. What we're going to do, and again, this is dirty, this is proof of concept, is I'm going to change an attribute in here. Again, you can drive this via a bunch of pieces. And we're going to change the chef serve attribute to 152. This means I'm going to build up a new system using chef provisioning SSH, connecting to the system that's got IP address ending in 152, and I'm going to drop the chef server recipe onto it. So to give you an idea of what this is actually looking like, this is the simple piece here. We are saying the install SSH URL, so where we're going to get that install SSH from. Instead of going from chef.io, I want to point it back to this system's FTP server. Again, you can serve it in whatever fashion you want. This is the method I chose for the demo. So it's going to grab that install SH, it's going to put chef client onto the system. Again, that install SH is pointing back to this box, or this workstation here. It has an FTP server running with the packages inside of it. And then we're going to pass in all the other options. And then the recipe we're running on it is just chef-server. we look at the recipe, it's pretty straightforward. We set the host name, and we start installing and reconfiguring the server and all of the other packages we want to work with. So really straightforward, and let's go ahead and run this now. So I'm running here is Chef Client 0, Chef Client local mode. As we mentioned in the keynote today, this all got merged into one, so they're all in the same code base now in that regard. And I'm passing in a -o, which just says override the run list, run this system. This is a really simple way to run chef provisioning. You basically tell the workstation that it's its own chef server, so they can do all the things it needs to, and then it's going to run through the provisioning piece, which will be connecting to the system over on SSH, and then on that system, running through its recipe to go through the process to make things happen. So we can see here that we created a bunch of directories. You see that execute extract gems, that's where I'm actually extracting the gems into the whole process. You can see underneath chef ingredient, chef server, action install, recipe dynamic defined resource, chef gem mixlib install, action install up to date, right? So chef ingredient requires it, it looks for it, sees it's already up to date because it's already in the path. And so now we've actually grabbed the package and we should be installing. It's actually probably going to be way too small for you guys to read. But here's the FTP server, and we can see that it just recently transferred Chef Server Core RPM. So grabbed that just a minute ago. So this is going to run for a little bit, right? Like I can't bend the laws of physics. It's going to take Chef Server, its own time to build and configure itself. So it's going to configure itself. It's going to run a reconfigure and do some other things like that. So while it's running, I'm going to go ahead and let's stand up a compliance server as well. And I'll make this bigger for you guys all in just 1 second. And did I say compliance? I meant supermarket. Oh, it won't do that until the other one finishes, but we'll go ahead and we'll go back into the slide deck while those run. All right, so the next part is, as we've gone through this, we've actually already solved the problems we need for the rest of the systems. In this case, we just need to change the piece of the recipe to go to supermarket.rpm, and we need inbound 443 on that system. So while this goes through, I don't have a demo of the workstation set up to it, but none of this actually requires you to be offline, or more likely requires you to be online. The process is the same whether or not you're on or offline. Once you get the packages onto the system, you're good to go. So the piece that we need for the rest of the infrastructure to work is the workstation to be set up to talk to the chef server. So we need a user on the chef server to talk to, and an organization to talk into as well. And then we need a knife.rb on the workstation, which tells the workstation where the chef server is and what to authenticate as, et cetera, and a user.pem to do the authentication with. So, hey, more of the same. Compliance server is the same deal. It's just got a single package, chef compliance. You need outbound 22 or SSH if you're going to use compliance to do ad hoc scanning. And you need inbound 443 to do chef client run data reporting. So for delivery, automate, the automate server, requires chef ingredient again. It also requires a few other things. It needs a license key, and it's got to be pointed to a chef server. So again, when we talk about the order of operations, right, what we really wanted to do here is, again, we need that chef server up to be that command and control point as we go through this whole process. Let's go ahead and check back in on the demo real quick. All right, so it has installed that package, 12.8.0. I used the current version of that one, so you get this big string there, and now we're into Chef Server Core Reconfigure. So that's just going to run. So while that runs, though, I can show you that I do, in fact, have on a different system, Chef Compliance, Chef Manage, and Supermarket. So, let's see here. How much time do I have?
18 minutes.
18 minutes. Okay, cool. So, so the nodes, right? So we've built the infrastructure, but we haven't really talked about the systems that we need to manage, which are the actual piece we care about. So the build nodes, if you're using Chef Delivery or Chef Automate, they need Chef Development Kit or Chef DK, and they need the push client. The rest of the infrastructure nodes just need Chef Client. The nice part about Chef is that everything is an omnibus package. What that means is we bring our stuff and all of our dependencies with us, right? So there's no reaching back out on the internet once you have the packages we need, unless you're going to use other things that are not part of the package, right? So if you're using different gems, if you're using different cookbooks, those things are not brought in by default. We need to bring them in. Again, from a security standpoint, the nodes just need outbound access. They need outbound to the Chef server on 443, and they need outbound 10,000 to 10,003 to push jobs. So, so that's really the kind of the core components of it. So what else, right? What's next? One of the things that I don't think I have a great slide on here is about Supermarket in terms of getting cookbooks. The reason why we want to build a Supermarket is that it gives us a way to share cookbooks between each other. So if we're different teams at an agency, if we're different teams in an enterprise, different programs in an integrator firm, right? Whatever the situation is, we don't have the ability to, one, go out to the internet and grab any cookbook we want, and two, the cookbooks that we write, we're not allowed to go share publicly, right? We're not releasing them in open source, but we do maybe want to share them, right? The way that I build Apache might be the right way for you. Within my organization, I can share within your organization, but the mechanisms are hard. So Supermarket is really important for that piece of the puzzle as we go through this. So, so a couple of the things that often come up is like, what if I have a proxy, right? Instead of I'm air-gapped, I'm in a proxy environment. I have access to the internet. I just got to go through this proxy thing. Most of the things support HTTP proxy and HTTPS proxy. Some things do not. We've tried really hard at Chef to make sure that all of our tooling, all of the Chef Development Kit tooling, supports it and understands it. That is true. Some of the other tools that you're working with probably don't. What we find, honestly, is that it's easier when you run into these situations to just say, screw it, I am going to assume that I don't have internet access, and I'm going to replicate everything I need internally, right? I'm not going to bother dealing with all this proxy nonsense to make this stuff happen. The firewall team doesn't respond to my requests anyway, so like, whatever. I'm just gonna bring this in. That makes sense. I highly recommend that method if you start running into problems with the proxy pieces. Don't sit there banging your head against the wall that you can't solve. Move on, get to the bigger problems that you have, get to solve the other problems that you have. That said, if you can poke holes to rubygems.org, supermarket.chef.io, and packages.chef.io, your life is going to be so much easier. Because you don't need to mirror the Ruby gems. You don't need to mirror the Supermarket cookbooks, right? All those things you can just grab from the internet, and there's not a whole lot of configuration you have to do. So, what's next, right? So we're getting close to wrapping this thing up. One of the things that you need to do in your organizations is define your process. How do we get code from development across the gap to production, right? So there's some mechanism, there's some process that happens internally. What does that look like? How do we automate that process? How do we get that at velocity, right? So the question you should be asking are, what tests do I need to run before I deploy to prod? What tests am I going to run in prod to ensure that the system came up properly, right? Before I walk away from the skiff and say everything's good to go. And how frequent do I have to do my packages, right? Because there's this air gap here, we often see the packages we run inside these environments are often really, really stale, right? What we want to do is we want to really quicken that process. We want to make sure that we get packages in quickly and often because, like OpenSSL, right, it's got vulnerabilities. There's a new 0-day just about every other week, it feels like these days, in terms of the packages and things we use. Here at Chef, we patch them really quickly, but that doesn't do you any good unless you have a process to get that patch into your environment, into the skiff that you're working with. So what about artifact storage, right? So I've talked about the Chef pieces, but really there's a whole lot more to running infrastructure than just running Chef. So you should have Artifactory or some other artifact repository that you work with. Again, these are decisions that you're going to make or you've already made about your infrastructure. Continue with those decisions, make the ones that make sense to be automated. Artifactory is a common one that we see in customers. It's a very popular one. It works really well. It does a really great job of doing this stuff. You don't have to run an FTP server running on your Windows workstation inside the skiff, which just feels wrong on like 17 levels. So do what makes sense. I have this really weird product X that requires that I have an internet connection. Can Chef fix that? No. We are not. We can't bend the laws of physics. We work to help you automate the tools and products that you work with and you operate with. And what we find is that we can make those things better. We can make it easier to work with. But if they have hard requirements, if their code is reaching out to the internet, I can't help you solve that problem, right? I just want to be very clear about where we do and where we don't help. So if you want the code, github.com/GalenEmery, chef-MRE. We'll go back to the demo here in a second. Actually, I'll just do that now, and then we'll answer the question if you want a USB key. So, coming here. So this is the supermarket one. It is reconfiguring itself right now. And there we go. So yeah, we're running on this guy. Is this one just finished? So there we go. And that was what, IP 10.152? Let's see if I didn't screw this up. I built something. There we are, Chef Manage. So again, once you build the process, it's really simple to build a new system and make it happen, right? So it's all about having that process. All I have to do now is just bring in the package, update the package I'm working with, and I can start pushing that out to all my systems. All right, so raise your hand if you'd like a USB key with this code. Okay, if you raise your hand, please let me know where your security clearance is so I can have it revoked. Do not accept USB keys from strangers. Do not pick them up from the parking lot. If you are at all curious about this, please read up on Stuxnet and Flame. Some fantastic stuff, maybe even written by folks who are in the room with us today. But anyway, that's pretty much it. A few things before we get into Q&A. I have a couple of acknowledgments I want to make. Thank you to those who are redacted for your help in making this process happen, giving me all the advice and information you have in terms of actually running this in your environments. Rob Kidd, Nell Shamrell Harrington, and Nathan Harvey are the supermarket team. They put in a fix just a couple weeks ago to make sure the supermarket ran an Airgapped world without any issues. It reached out to Bing and a couple things for some graphics and stuff, and they brought those in and made that happen for us. Also, thank you to two of my colleagues, Ricardo Luca and Jim Murphy. They're super great in terms of presentation advice and help as we go through the process. And so I also need to recognize Rob Kidd again, because a couple weeks ago he reached out to me internally and said, hey, I see you're talking about ChefConf on Don't Mind the Gap. I'm like, yeah, oh, cool. And he sent me a link to the 2014 ChefConf, where he's had a presentation called Mind the Gap, talking about running Chef in unforgiving environments. So thanks to Rob for letting me steal his title, not getting mad about it. And also, you should go check out his talk. It's up on YouTube. To search ChefConf, Rob Kidd, Mind the Gap. You'll find the YouTube channel. Last piece. So these are some other talks that I think are worthwhile to go to, check out. Right now, I already mentioned this one. Michael from Minder is talking about DevOps in the IC. It's going to be really powerful and important. Sean Walberg from the NFL is talking about breaking technology silos with Chef. That's just really cool because the NFL is talking about DevOps, and I love football. DevOps Gateway for the Healthcare Enterprise is tomorrow. They're talking a lot about some of the similar problems that we face in the IC and the DoD communities. So they have a similar problem space, and it's really important for us to learn what they are doing as well. We got a couple talks from Booz Allen as well. Actually, the talk you're not in right now, which would be really good, is SAP NS2. We're with them a lot. They're over in the Salon Ballroom. And they're talking about their journey as well. So definitely check out that recording when that goes online. So Wyatt Chaffee and Jimmy Pham from Booz Allen are talking about how they adapted the DevOps pipeline for Chef delivery. And then also Nirmal Mehta is talking about how to achieve compliance at DevOps speed. So he works at Booz Allen Hamilton and talks about those. All right. What questions can we answer? I guess we is not the right word. What questions can I answer?
First, I want to say thanks for the market fix.
Are you guys making sure
So Chris asked the question, are we making sure that we are, that we're ensuring that our products are built in a way that they don't reach out to CDNs by default? Yeah, we built more processes around that. We had a big initiative about a year ago for a bunch of the tools to ensure that they did that. If any of you have installed delivery via the delivery cluster cookbook, you also have noticed that that thing goes through the internet. There's actually a new way to install it. It's called, it's from the Dazzle team. We have weird names inside Chef sometimes. But, so that actually uses RPMs. We actually folded delivery CLI and stuff into the Chef development kit and did some things like that. So now all of our tools do in fact truly install offline, really easily and smoothly. And we are ensuring in our processes that, that we're not reaching out to the internet.
Where do you find these RPMs?
Yeah, so the question is, where do you find the RPMs? If you go to downloads.chef.io, you can get a list of all of the main products. Also, if you go to bintray.com/chef, that's actually the full definitive list of all the RPMs we have for Chef. For all the versions of Linux you're working with, all the versions of Windows. That's also where you can find the current branch. So if you're interested in checking out the new bleeding edge stuff, you can go there and check it out there. In the back.
I heard you say that mirroring Ruby gems is not a feasible solution, but why is that?
So you can mirror. So the question is, why is mirroring Ruby gems not a feasible solution? There's two pieces to it I think that are really important. One is that it takes a lot of space and a lot of power to host a Ruby gems mirror. There's a lot of things on Ruby gems. I think setting up a gem mirror, like a gem repository, and having API calls to talk to it is in fact a good thing. What you should not do is grab every Ruby gem from Ruby gems. And the reason for that is a couple things, right? You're downloading, and we talked about this at Chef, you're downloading source code from the internet that's going to run as root on your systems in your hardened environment, right? Like, that's a scary thing. So be very selective about what you're doing. Again, put in the right controls in your place to ensure that you have the right security and responsibility around it. And those vary depending upon where you are, right? Some places I know literally walk through every line of code to ensure they understand what it's doing before it runs. Some places are like, oh, that was written by Chef, or that was written by JJ at Chef. So like, I totally trust that, right? And it's up to you. I can't make those decisions for you. I say that you can, you know, in a typical fashion, you can trust things from Chef are not going to be malicious in nature. They may still have bugs, right? And so you want to be aware of that. And this is where having a pipeline is really important, right? And I think this is really what it comes down to is if we build the workflow, right? If we build the workflow appropriately, we actually have a really good confidence when we go to deploy it into production that we know what we're deploying and we know what issues we're going to run into and we shouldn't run into it in production.
Last time I checked,
What are the current thoughts on packaging server applications and Habitat?
What are the current thoughts on packaging the server applications in Habitat? Yeah, I wanted to do that because I thought that would be really cool. I am not smart enough to have done that before this talk. So I don't know, and also like I'm actually a little surprised I haven't seen anybody like build that and show me that. I think that that's going to be a thing that happens, right? The packages themselves, the server packages, we've been building them to be their own kind of package repositories already. So it's not as big of a deal for Chef server packages as it is for other tools and things that you're working with. The big thing that I'll say is that I think there's a really good space for Habitat to help solve particularly some of that like gem dependency management stuff, right? Like, and even the cookbook dependency management stuff. I think there's some good spaces there in which you can get the true artifact really, really easily. And I think there's a lot of power there, and I just haven't explored it yet.
That kind of leads into what I was asking. Is Chef DK more important than like the mainstream Ruby, the latest Ruby? And
Can you repeat the question?
like, you know, how does Chef DK give you benefits over the mainstream Ruby?
So what are the benefits of Chef DK over mainstream Ruby, right? So over just having a system Ruby. There's a number of things that we give you with the development kit that are really powerful. And I didn't show those today. A couple of things are we have wrappers for a bunch of pieces. So we have a chef generate command, which allows you to generate cookbooks, recipe files, etc. It builds them in the proper method, puts the correct headers on the top of them, right? All that stuff is built with that. There's also Bergshelf, which is Dependency Management. Bergshelf by default is what you're going to use to go reach out to supermarket.chef.io and grab cookbooks. But it's really just a one-line change inside your cookbook to say, I don't want to reach out to supermarket.chef, I want to reach out to my internal supermarket. So those are the tools as well. Test Kitchen, written by Fletcher Nickel, who's here. He's talking tomorrow on Habitat at 1 p.m. in the Habitat. And so he's a fantastic person, and Test Kitchen does a great job in terms of building and managing a VM so that you can run it through a testing cycle, right? So I didn't do any of that in my demo today, but that's really what one of the things that should be done as part of your process, part of your pipeline. There's a few other things as well, but those are the big components of the Chef development kit that are really valuable. And also it comes with Chef Client, right? So Chef Client's there as well to give you access to Chef Client-Z and anything else you want to run. All right, well, if there's no further questions, then I'll go ahead and let you all go into the hallway track. Thank you all for coming. It's been a pleasure talking to you.